Hello, everyone. This is the first after summer vacation period FAUG live meetup, which we organize bi-weekly. And you can find some information about FAUG from the meetup website and from internet. If you Google FAUG meetup and Finland Azure user group YouTube, there is a channel with all the videos available from the previous presentations. And FAUG is the Finland Azure user group, which organizes multiple events. There are around 10 yearly events, and one of the biggest events is the IGLUConf, which is not yet decided on what will be the format of that during upcoming, the next one. So let's jump into the session then next. So hello everyone and welcome to Finland Azure user group, Virtual Azure Tips and Tricks Extravaganza, to the MAX 2020 session, where I'll be talking about creating event-driven applications on Kubernetes with KEDA. And I want to apologize in advance in case you will be hearing some construction noises, as my neighbor recently started renovation, but I asked him to be quiet during this time, so let's see if he can deliver. So today's topic is event-driven on Kubernetes with KEDA. And let's start first about a couple of words about me. My name is Yuri Barseghyan, so I'm Cloud Data Architect at Tieto, working with Azure since May 2018. I have like over 10 years of web development experience with languages such Scala, Java, JavaScript, Ruby, Python, and all the relevant frameworks. And my professional and personal interests are in the cloud and big data, microservices, and the Kubernetes. A couple of words about the company where I work. So about Tieto. In 2019, there was a merger between Tieto and Evry, and guess how they named the company, Tieto. We are 24,000 experts globally, and we serve customers in more than 90 countries. Annual turnover is around 3 billion euros. It's publicly traded company, and the share price, the last one I checked, was around 25 euros, a bit under. And in January 2020, Tieto and Microsoft announced strategic partnership in public cloud services. So a bit about the team. I work in the Tieto data platform for health team and healthcare organization. We are about 50 professionals working with Finnish healthcare customers and building Azure-based healthcare data platform for supporting various use cases like data science, research, machine learning, data-driven applications, and reporting. And of course, taking into account all the security and privacy requirements of the healthcare domain, pretty regulated healthcare domain. So a couple of words about today's session. So we will be talking about a bit cloud-native computing foundation. Then we will go into the Kubernetes, and the main topic is, of course, the Kubernetes event-driven autoscaling, aka KEDA. And we will have some live demo where we will try out KEDA. So let's start with Cloud Native Computing Foundation, and what is it? So it has been, the CNCF is a Linux Foundation project, and it has been founded in year 2015. And the main purpose is to advance container technologies, and it has been announced alongside with the Kubernetes 1.0, which has been contributed by Google to the Linux Foundation. So that was the first project kind of to start with with the CNCF. And founding members include like Google, Intel, IBM, Docker, and many other big ones. Nowadays, the list is much bigger. And in August 2018, Google actually handed over the whole operational control of Kubernetes to the community. CNCF project, there are three main types of projects in CNCF, Sandbox, Incubating, and Graduated. And they correspond to the innovators, early adopters, and early majority tiers of the crossing the chasm diagram. So at the moment, there are 11 graduated projects, among which are the most famous ones are Kubernetes, Helm, and Prometheus. There are 19 incubating projects, and there are 33 sandbox projects. And as you can see, the KEDA is one of these sandbox projects in CNCF. There are over 1,000 member products and projects from various member companies. So Microsoft is a platinum member with 16 member product and projects. You can see the list of them. And as a part of the CNCF, there is a local cloud native Nordics community. So it's a joint community across the Nordic countries. There is a Slack channel. I'm a member of the Cloud Native Nordics as well. There is a Slack channel that you can join, and there are some events organized in Finland, Kubernetes and CNCF Finland meetup in Tampere, Turku, and Helsinki. And of course, in other Nordic countries as well, you can find those. So let's now talk about Kubernetes and start with it. So what is Kubernetes? Kubernetes is an open source system for managing containerized applications across multiple hosts, and it provides basic mechanisms for application deployment, maintenance, and scaling. And as you can guess, scaling is the main topic of today's talk, so we will concentrate on it a bit more. Managed Kubernetes is provided by all major public cloud providers. The latest Kubernetes version is 1.18.8, and supported latest Kubernetes version in Azure as a AKS. The newest is 1.17.9, and the 1.18.6 is in preview. So it's quite recent, I would say, the version of the Azure, especially if you consider the preview version. So what's so special about Kubernetes, or in general about containers, let's say? So if we take a look into traditional deployment era, when we were deploying the applications were running in physical servers, and there was no any resource allocation. You couldn't allocate specific resources for a running application, and the boundaries of the resources were kind of like loose, and there was no way to define how much resources the application will be using and how many applications to run and all that kind of thing. So then came the virtualized deployment era, where we started using VMs, and VMs, the virtualization allows you to run multiple virtual machines on a single physical server CPU, and it allows application to be isolated between VMs and provides a level of security. But each VM is a full machine running all the components, including the operating system on top of virtualized hardware. So it creates some kind of layers, as you can see. And nowadays we live in the container deployment era, where containers are considered lightweight, as they have more relaxed isolation properties, and they are sharing operating system among all the applications. And similar to VMs, they have their own file system, CPU memory, process space, and so on. And as they are decoupled from the underlying infrastructure, they are more portable and cloud agnostic, and so more portable from that sense. So if we take a look into the Kubernetes main kind of building blocks, to refresh the memory, we have pods, which are the logical unit of the application, and it can contain one or more container. Then we get nodes, which are VMs serving as a worker in the cluster, and pods are running on the nodes. And then we have the cluster, which consists of the worker nodes, and is managed by the control plane. So as a main building blocks, and there are multiple scaling options for the Kubernetes, and Kubernetes as a whole. There are manual scaling options. There is a load-based scaling, which includes cluster autoscaler, virtual kubelet, horizontal pod autoscaling, and event-driven scaling. And event-driven is a separate scaling mechanism, which is going to be the last part. So let's take a look into them in more details. So with a manual scaling, you can scale a Kubernetes objects. So if you run the following command, you can scale specific deployment, for example, to use 3 replicas of the same application, and then you can scale manually the Kubernetes cluster itself, and this is like cloud specific. So in case of AKS, you can execute the following command, and then you will get the scaling. So it's like manually you can define what should be the size of your cluster. But not all the objects can be scaled, and specifically for the Kubernetes objects, of course. Then we have the load-based scalers, which are cluster autoscaler is the first one. So if you create the cluster, if you enable cluster autoscaler in Kubernetes, then it will be watching pods that can't be scheduled on nodes because of resource constraints, and then cluster then automatically will increase the number of nodes. So it's like a plugin, and then it takes care of decreasing the number of nodes as well if the load goes down. And you can execute, enable the cluster autoscaler during the cluster creation. In case of AKS, that's the command to run, where you will define mean and max count for the cluster, or you can enable it for existing clusters if it hasn't been enabled during the creation time. Then we got a virtual kubelet, which is another Kubernetes feature, and there is a specific implementation on it with specific cloud provider. So in case of virtual kubelet, nodes are backed up by other services. So in case of AKS, it is using ACI underneath container instances, and in case of AWS, for example, it will use AWS Fargate. And virtual node functionality in AKS is heavily dependent on the features of the other services. So in case of Azure, of the features ACI, and there are some limitations. Some of them are, for example, you can't pull ACR image using service principal. Then there are some virtual network limitations, and it requires you to use Azure CNI as a networking within the Kubernetes cluster. And the final one is a horizontal pod autoscaler, which is the like HPA is automatically scales the number of pods based on observed CPU or memory utilization, so it's resource based. So a horizontal pod autoscaler will be monitoring or like getting metrics from the metrics server API. And in case when pods report high CPU load, then horizontal pod autoscaler will add more pods and scale the amount of pods. Minimum pod count is 1, and so you can't scale to 0. There should be at least 1 pod running, and not all objects can be scaled. So not all Kubernetes objects. So there are other 2 types of custom metrics, pod and object metrics. But if we are talking about resource metrics, the CPU and memory, they are kind of custom, the cluster specific, Kubernetes specific. So you don't by default get any functionality of like resource outside of AKS having some high load or like there is too much data coming in that you will be able to scale it up. Though you can like scale up based on the, for example, incoming traffic amount using the pod or object metrics actually. So HPA deployment, there are 2 ways to deploy HPA. It's imperative and declarative with Kubernetes. Those are always available. So the first one will define like the imperative way, you define like your CPU percentage, min, max count. And with the declarative, you have the configuration file, which you apply towards the cluster, and cluster takes care of creating what you request. And in this case, we can see that we say min replicas are 1, max replicas up to 10, and the target CPU utilization percentage is 50. So if it goes over 50%, then we will get the scalar HPA will kick in, and we will get more nodes, more pods running. So this one is working on the pod level. The previous ones are more working on the extending the amount of nodes actually. So next, let's go exactly into the main topic, Kubernetes Event Driven Autoscaling, aka KEDA, and what that brings. So it has been launched in 2019 by Microsoft and Red Hat. It's pretty new. Version 1 was released in November 2019, which makes it production ready with the needed security level. It has been accepted as CNCF Sandbox project in March 2020, again, pretty recent. and latest release is 1.5.0. So, and what's the purpose? It's so the KEDA acts as an external metrics aggregator, and it adds ability of autoscaling on actually any arbitrary external metrics. So you are not limited only by the Kubernetes internal metrics, but you can integrate with any other external metrics provider and scale your pods. It allows you to use 0 to n scaling. So actually you can have a no pods running, and then it will trigger for you like it will scale for you from 0 and can go down to 0. And it has no external dependencies. So you just install it to the any Kubernetes cluster and it just works there. Let's take a look into architecture. So it consists of three main components: the scaler, controller, and metrics adapter or metrics server. So the controller is in charge of scaling the deployment from 0 to 1 and vice versa. And the scaling from 1 to n instances is handled by using the HPA. So the controller, when it scales from 0 to 1, it will create HPA for you, and then the rest scaling happens by the HPA. And same way, if it goes down, the HPA will scale it towards the 1, then it will scale down, remove the HPA and scale down to 0. HPA will consume the custom metric server to determine if it should scale out further. So it's actually consuming the metrics server from the KEDA. And the scalers are defining what external resources should be monitored and will report metrics back to the custom metric server. So that's the main components. And so underneath KEDA is actually just taking care of scaling from 0 to 1 and from 1 to 0, and provides the metrics for the HPA for the rest of the scaling. So it's utilizing Kubernetes' own internal functionalities. There are 21 scalers implemented at the moment, more to come. The list is growing all the time. Among them, you can see from Azure specific, like Azure Blob Storage, Azure Event Hubs, Monitor, Service Bus, Storage Queue. And there are, for example, some databases like Postgre and MySQL. So there, the functionality is such that you can define a query which should return you integer, and then you define a threshold. So if the query returns a value which is over threshold, then your autoscaling will kick in, and then you will get the KEDA will start scaling your pods. And it's very easy to install the KEDA. So you can use Helm. There are multiple ways, but like here are examples of using Helm 3. So you just need to add the repo, KEDA core repo to your Helm repositories, update the repository list, then create a namespace in Kubernetes for KEDA and install it into the namespace. Or you can actually use the Azure Function core tools to do it. So with the lower command, but at the moment it has been broken. Maybe I have a bit older version. I didn't try with the newest Azure Function core tools, but at least like when I was testing it today with a bit older version, it was still broken. So I would recommend using Helm. In all cases, it's much easier than getting rid of it as well. And now let's go to demo actually. So let's take a look what I have at the moment. So here we have Kubernetes cluster, and I have a storage account. So my demo will be based on a storage account queues, and I'll be running Azure Functions. For that, we will utilize the existing GitHub repository from the KEDA core itself, and just go through it, and you will see how easy it is just to set it up. But I have a Kubernetes cluster, I have a connection to it, so let's see. So as you can see, we don't have any pods running, but if I'll take a look into my node, so I have like one node running there, and we can take a look into the namespaces to see that there is no KEDA installation yet, so there is no KEDA namespace here. So let's go through the demo. So yeah, create a folder. I have already that one, so it's just an empty project. So first we need to initialize the directory for functions. So it will just create for us a functions project, and the Docker just will add. So we initialize it with dash docker, which will enable for which will just create for us a Docker file, which will be used later on for the KEDA deployments. Then we use the node and the JavaScript. That's what the example is using. And then we need to create, and if you have the already Azure function existing project, then actually you can just create for it a Docker file. So there is another, I think it's dash Docker only, and then it will just add the Docker file for your project. And it's pretty simple Docker file. Then we need to create our function actually. And we will be using Azure Queue Storage Trigger, so it's number 10. And let's keep the function name the default one. So that's done. Next, I'll actually copy over one file, which I'll be using later on. So it's queue populator. So it's just a simple function, bash script, which will be just adding new items into the queue for the consumption and for the scaling to happen. Yes, so I have the files. Let's see next. So then next we need to create the queue in our storage account. So let's go to the storage account. And we are gonna use queues. Let's make it bigger for now. And I'll add the queue with that name. Okay, and let's actually no, we don't need at the moment it. And next, I guess we need to provide a, so now we need to work a bit with the files. There are a couple of settings that we need to change. First, we need to provide a connection string for our function that it will be able to connect. So we pull that one from here, copy, paste, and I'll be actually using that one also for my bash script as well, because it's going to utilize the same one. Yes, done. Let's see. So let's go to the queues, and the next, I think we need to update the function actually, the FAUG function JSON file to say that it needs to read the connection string from the Azure Web Job Storage variable. And we should be, yes, that's it. This is not really needed nowadays. So we can just try it. So we will run our function locally and just test it locally to see that it's actually working and it's able to connect to the queue and consume items. Okay, so it's started. So let me add some kind of, sorry, this is the queue. So let's add a new message and let's see that it's actually getting read by the function. Yes, so it works fine. And let's refresh to see that it's gone. Yes, so it has been consumed. So we have a function working. Now we need to deploy it into the Kubernetes. But first, of course, we need to install KEDA. And as I said, it's pretty simple. Here is the deployment with Helm. You can see the commands here. It's from the official KEDA site. And we will be using Helm 3, as I said. So I have already the repo added and updated. So I just need to create a namespace. And I need to just install the KEDA into that namespace. Okay, it's done. And we actually can check it by, first we can see in kubectl get namespaces. So you can see the KEDA namespace, and then we can see all the pods running. So you will see that there are 2 pods, the operators and metric server running actually in the KEDA namespace. Good. So KEDA is there. So as you can see, it's very simple and pretty fast. So next we need to pack our Azure function into the Docker as a Docker image, and then deploy the Docker image into the Kubernetes. And it's very simple again. So we just need to execute. So for that you need Azure, or not Azure, you need a registry, Docker registry, where you will be pushing your images. And you can use, of course, the Docker Hub and public ones, or then you can use the private ones. But in that case, you need to then define the pool secret. There is information in documentation about it if you are looking. But in demo, I'll be just using my own registry and as a public one. So it's called ubarsec. Yes, so here it is. As you can see, there is no repository with name hello KEDA, and what I'm saying that I want to deploy into the Kubernetes the function with the name hello KEDA, and I'm using the registry ubarsec. So what this does underneath, it starts building my Docker image based on Azure function, and then it's pushing it into the Docker app. So it's built it already, so it built, and now it's like pushing it, and we should see it after some time in the Docker Hub. And after that, it's actually straight away deploys it into. So if you want to see actually what this creates, you can say dry run and actually see what objects are getting created. And we can take a look into some of those. So as you can see, there are some secrets created for us. There is a deployment, and this is the main kind of scaled object. Those are the KEDA objects. And there is information about exactly the different triggers, what's the queue named, about application, and so on, what is getting monitored. So there is some information about the scaling and objects. You can see some stuff. So you can actually update this and add more. So if you don't want to use defaults for the polling interval, cooldown period, and min-max replica counts, you can update it and just deploy this using the Kubernetes apply command yourself without using the core tools, function core tools. And as you can see, it's kind of by default, it will be polling every 30 seconds. If there are no any new messages, it will start scaling down in 5 minutes. The mean count is 0 and the maximum is 100. And if I'm not mistaken, it's using the queue size is 5, so it waits until there are like at least 5 items and like in the queue which are not consumed, and if it's more than 5, then it will actually start consuming those. Yeah, the triggers are different. So yes, so now we have it already running actually, and we can validate it, so we actually don't even need the project anymore. We can validate it by running the pods. So sorry, yeah, as the default mean replica count is 0, so actually we don't have. So as you can see, there are no any, those are all system pods, but if we run just or I have just a shorthand for this, kubectl get pods, you can see that there is like nothing in the default namespace. But if we check kubectl get deploy, you can see that our hello KEDA is running, but there is only 0 instances because that's what we defined. So it's having 0 replica count. So now we need to add some load and see actually that we are getting the scaling working. So for that, I'll just put it into monitoring, and let's run our queue populator, and let's populate it with 50 items. So it starts pushing, nothing yet happens. We can actually just check that messages are coming into the queue. Yes, so you can see them available already. And at some point, of course, whenever like it hits the 5 minute, okay, so it's already hit like, and we can see that there is already the scaling ongoing. And if we start refreshing, or actually there is no yet running pod, so when there will be first running pod, then those messages we should see that start disappearing. And yeah, already we have some. If I'll start refreshing, maybe, yeah, from time to time you will see some message available. So if we check what's the situation now, we have like 3 pods running, and they are consuming all the time the queue, and soon I guess I'll run out of the messages. And after the period of 5 minutes, then the KEDA will start scaling it down, and it will scale down again to 0. So that's about the demo that I had. Let's see if I forgot something. And yeah, of course, there is the, as I was saying, yeah, you can use the virtual node, so you can actually deploy, and that's a very powerful feature, in my opinion, that you can deploy those pods on the virtual nodes, which will mean that if you have actually very high burst of the data, incoming data, you will be able to scale much faster with the ACI. So the pods will be allocated and deployed into the ACI container instances. But for that, you need to just like enable that functionality. So again, you will need to work a bit with the Kubernetes configuration files and enable that it's kind of able to allocate. If you have the virtual nodes, then able to deploy those pods into the virtual nodes. Yes, and that's, I guess, it. And there is like, then you can clean up, delete the items and so on, but we don't really need to do it. And we can, of course, wait 5 minutes, but I guess we can take a look into that later. So that's about the demo. Then there are some resources about the CNCF, Kubernetes, KEDA. Then there is the repository link from the GitHub repo that I have been using for the demo. And that's it. So now time for questions. And if you have any question, please use the YouTube for writing it down. Oh, nice. Great. Hi, Tom. Looks like you are watching it. Thanks. Yeah, nice, nice. I didn't know about the version 2. Okay, I'll wait a bit more. Not the good question, at least, like about the scalers. I think at least I am well covered from the scalers. We are quite a lot using Kafka, so there is a Kafka. I mean, I didn't really try it yet, and a pretty nice feature actually about it for testing all this out. You don't really even need to have AKS or anything, so you can run all that setup on your own Kubernetes, on your own machine, on-prem, or wherever you want, as there are no any external dependencies. So you can actually test this out with some Kafka cluster running on your own machine, and like you don't really need even any Azure subscriptions for like trying out those. One actually thing what wasn't working for me, I actually made the request in the GitHub about it. With Event Hub last time I tried, and the repository has been for the Event Hub example updated quite a long time ago. It didn't work really, so it was like very buggy working with the Event Hub. So, and there was a ticket open for it, so I didn't get any response for it. So if you can take a look, Tom, into that, or anyone else, like that will be great, because Event Hub is actually the storage queue, just works easily, and it's the most easiest one to demo. But at least with Event Hub, it's a bit more buggy, I would say. Let's say maybe I last time I've been trying it out was like a month ago, I guess. So maybe recently it has been actually updated. So that's it. Oh, and actually we can see that termination is happening now. It's terminating, and most probably it will soon get terminated. So that's about the demo, and I guess that's it. So thank you very much, and good luck, and keep safe, stay safe in these Corona times. Bye bye.